Example 2, we're finding the values of the 6 trig functions. I think that makes it a little bit difficult because we've got a lot of stuff to do. On your homework, I think it's just going to ask you to find, maybe it just asks you to find sine theta, or maybe it just asks you to find cosine theta or something. Maybe it just asks you to find 1. But when we have to find all 6, then remember what we have to do. We've done this, we haven't done this in a while, but we did this a lot in chapter 5 and maybe in chapter 6. But we had to find all 6 of those trig function values of theta. So look at what you have given. Cosine 2 theta equals 4/5, and 90 is less than theta is less than 180. So think about what that means. Between 90 and 180 is talking about the second quadrant. Okay? 90 degrees and 180 degrees, they're talking about quadrant 2. And so I feel like they're describing the picture, but whatever. Look at what you have given. Cosine 2 theta equals 4/5. So what you probably want to do to start with is start with your identity for cosine 2 theta. Cosine 2 theta. You've got 3 options for the double angle cosine, and so we can start with any of the 3. But I would probably recommend you start with one of them that only has one identity on the other side, one function on the other side. So if I want to find sine theta first, let's use the cosine 2 theta identity that just has a sine theta. 1 minus sine, always forget that too. 1 minus 2 sine squared theta. Okay? We're going to fill in the blanks as best we can. We're going to solve for sine theta. I know cosine 2 theta equals 4/5, so we should be able to fill that in right there. 4/5 equals 1 minus 2 sine squared theta. I'm trying to write small because we've got a lot of stuff to write. If I'm going to solve this, I'm going to isolate the sine theta, basically. And so isolate just like any other algebra equation, we're going to subtract 1. And that's 5/5. So if I subtract 5/5 there, it's going to be 4/5 minus 5/5 is -1. -1/5 equals -2 sine squared theta. If I'm trying to isolate sine theta, I'm going to divide by this -2. Now here's the little trick, okay? I've already got a fraction bar there. I've already got a division sign there. So when we divide by -2, it's just going to go underneath the fraction, or on the bottom with 5. I'm dividing by -2 and I'm dividing by 5. Okay, so that's like -10. I would have -1 over -10, or positive 1/10 equals sine squared theta. So almost there. I just have to take the square root of both sides. Okay, if I want sine theta, I'm going to square root both sides. Actually, it's plus or minus square root. But remember, we're in the second quadrant. So what do we know about sine in the second quadrant? Sine in the second quadrant is positive. So we're just looking at that positive root. Square root of 1 is 1, so we have 1 over the square root of 10. That's sine theta. Or, once you rationalize, sine theta equals square root of 10 over 10. That's part of our answer. This question asks me to find all 6 trig function values. Maybe on your homework, though, we'd be finished. Maybe it only asks you for sine theta on your homework, and you'd be finished. Now, once you've got one of them here, and we need to find the next one, probably going to find cosine. You've got some options. You could go back to your cosine double angle, or you could go to your Pythagorean identity, sine squared plus cosine squared equals 1. That might be a good way to go. You've got several different options. Just pick one and go with it. I think maybe we'll go with that. Sine squared theta plus cosine squared theta equals 1. Okay? So, go back to right here where we had sine squared theta. It's 1/10. Or I suppose you could take your sine theta and square it if you want, but you're going to get 1/10 there. Plus cosine squared theta equals 1. I'm going to solve for cosine theta. So let's subtract the 1/10. And cosine squared theta equals 9/10. You need to take the square root of both sides, plus or minus, right? But again, remember, when we do this, we have to remember that we're in quadrant 2. And what do we know about cosine in the second quadrant? That one's going to be negative. So we're looking at the negative square root of 9/10. Cosine theta is going to be negative square root of 3, or negative square root of 9 is 3, over square root of 10. Or rationalizing that, cosine theta equals negative 3 square root of 10 over 10. So now we've got cosine theta. Tangent theta, again, I've got options, but I think the easiest way to find tangent theta is do a sine over cosine. So if I was going to do tangent theta, I might do sine theta over cosine theta. And so we're going to divide our sine theta value over our cosine theta value. Now, here's a hint. The unrationalized version has the smallest numbers, and it's going to be easiest to work with. So I'd probably go back to my unrationalized value for sine, 1 over square root of 10. And my unrationalized value for cosine was negative 3 over square root of 10. I think it's easy to see what's going to happen. Square root of 10s are going to cancel. If you multiply by the reciprocal, square root of 10 over negative 3, you're going to see those square root of 10s cancel out. You get negative 1. So tangent theta equals negative 1/3. There are your big three. So find the other three, the reciprocal functions, just by flipping. So I know cosecant is the reciprocal of sine. We're going to do the reciprocal. Again, go back to your non-rationalized version when you're going to do the reciprocal. That's going to be the square root of 10 over 1. Square root of 10. When we do secant theta is the reciprocal of cosine theta. And again, go to your unrationalized. When you flip, we've got square root of 10 over negative 3. Negative square root of 10 over 3. I don't like that negative on the bottom. We'll put it on the top. Negative square root of 10 over 3. And for tangent, for cotangent, reciprocal is negative 3. That's all 6. Now again, I did all 6. That's a lot more work than I think you're going to have to do on your homework. On your homework, they'll just pick one. But it's the same process. Find an identity, and then basically isolate your